Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome to Wednesday Math Night. I am Amy Sink. Thank you, Dr. A, for that awesome introduction. This is my dog, Pudge. Apparently, he's trying to make a cameo today. He's a Great Dane. So sometimes you'll see him in the videos. So everybody say hi, Pudge. Say hi, buddy. So I am Amy Sink. I am so glad that you are joining me here today. Like Dr. A said, I am going to go over about 10 problems. It seems like we've been averaging about 8 recently, but I will be going over about 10 problems that range from pre-K through 12. Now, while I'm working through these problems, I encourage you to ask questions. So if you're like, hey, I really didn't quite get that, or could you slow down, or could you show me that problem again? I'll be more than happy to pause, slow down, answer any questions that you have. Also, as I'm working through these problems, if there's an area that you're like, hey, I really need help with formulas for area, or I really need help with linear equations, or I really need help with the quadratic formula, whatever you need help with, leave that in the comments too, because that helps me build the problems for the following week. So without further ado, actually, let's get to know each other for a little bit. So drop in the comment section where you're from and what test you're prepping for, because that really helps me understand who's in this room and who's taking this Wednesday night math session. So if you let me know what test you're prepping for, it helps me guide the kind of the rabbit trails that we go on with these questions. The questions are preset. However, how I explain those questions is obviously not preset. So if you leave me a comment to let me know where you're from and what test you're prepping for, that would be super helpful. I am from Central Florida. I am a math coach in Central Florida, and I am certified K-12. That's a little bit about me. Hello, Sean. Hi, Andrea. It is awesome that you guys are here. Hey, Hope, it's good to see you again. I'm from New Mexico, prepping for the Praxis Corps. That is awesome. And Pudge says hello as well. So without further ado, let's go ahead and get started with our first problem. The graph to the right shows the amount of gas in gallons a boat uses over the course of time in hours. What is the slope of the graph and what does it mean? So what they just told us is that this graph right here represents the amount of gas a boat is using over the course of time. So what I need you to understand is that we've got our x-axis here and we've got our y-axis here. And when we're dealing with coordinate planes and we're dealing with problems on a coordinate plane, we have to understand what is the independent variable and what is the dependent variable. So we have to understand what is the independent and what is the dependent variable. Now, you might be saying to yourself, Amy, that's totally science. That's not math. It is math because it helps us understand how we're going to graph on the coordinate plane. So our independent variable is always going to be our x-axis, and our dependent variable is going to be our y-axis or our y-coordinate. Why? Because we're doing the x first. So if x is 2, then y. You can think about this as the x and the independent being the if and the dependent being the then. So if blank, then blank. If x is 2, then y is what? X is kind of controlling that y. So when we look at this boat graph, and we know that the graph is going to be that blue part, the boat part is going to be the blue part, and it says, it shows the amount of gas over the course of time. So which one of those is going to be independent and which one of those is going to be dependent? I apologize for the noise in the background. Which one is going to be independent and which one is going to be dependent? The independent is going to be the time. The time is just going no matter what. The time is not depending upon the gas in the boat. The gas in the boat depends upon how much time has been driven. So our time is going to be on our x-axis, and the gas is going to be on our y-axis. So now that we've identified that, because they didn't identify our axes for us, now that we've identified that, what do we notice about the blue line? Well, the blue line is going down. How do I know it's going down? How come it's not going up? It's a great question, because if I go from this side of the graph, it's definitely going up because we read from left to right. So when I read words, I'm going from left to right, from left to right, from left to right. When I read math graphs, I also go from left to right. So I'm going to start here and go to the right, which is why my graph is going down, which means it's a negative slope. So because my graph is going down, I know that this has a negative slope. What else do I know about this graph? Well, if we talk about what this graph means, the gas is decreasing as time goes on. So as the time progresses, the amount of gas in my tank decreases. Well, conceptually, that makes sense, doesn't it? So let's look at our answer choices and choose the best answer choice. The slope is positive 2/1. The boat uses 2 gallons of gas for every hour it is traveling. I can automatically cross that off because we already determined that the slope is negative. Letter B, the slope is negative 2/1. All right, that has a negative slope. I'm just going to keep going and cross off all the answers that have positive slopes first. The slope is positive 1/2. Nope. my slope is not positive. My slope is negative. So I'm going to keep moving. The slope is 1 over negative 2, which is the same thing as negative 1 over 2. So now I just have to determine, is my slope negative 2 over 1 or 1 over negative 2? And what does that slope represent? So how do I figure out what my slope is based on a picture? Well, I'm going to find a crossing point or an intersection point, and then I'm going to count. So I have a point here where it crosses, here, 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 and here. And I know that slope is rise over run, or the change in y over the change in x. That triangle just means change in, which means y minus y over x minus x. So I'm doing the y change first and then the x change next. So to get from this point to this point, how much change am I going up or down? I'm going down 1. So I'm going down 1. And then how much change is happening to the left or to the right? I'm going to the right 2. So my rise is negative 1 and my run is positive 2. Remember, I just said 1 over negative 2 is the same thing as negative 1 over 2. Now, what if I went from this dot to this dot? I could do that. I would be going up 1 and then running 2 in the negative direction because I'm going to the left. So either way, I end up with the same slope, which means D is my answer. So what we notice is that the boat is using a half gallon of gas for every hour it's traveling. How do I know that? Because at time equals 0, which is right here, at time equals 0, I have that much gas. After 1 hour, I've only gone down by a half of a gallon. After 2 hours, I've gone down that full gallon. So after every hour, I'm using a half gallon of gas. Does that make sense? All right, let's go ahead and keep going into our next problem. Now, this was a leftover problem from last week. You can always tell which problems are leftover problems because they're going to have a star. So they're problems I'm pulling in from the week before that I didn't get a chance to go over. Now, if you would like a copy of these blank problems, you can go ahead and text the number that's about to pop up on the screen. You can text this number and you can text MathStream1 to the phone number and they'll go ahead and send you a copy of these blank slides. That'll allow you to go ahead and go back and practice these problems at a later time or practice the problems that we didn't get to and then I'll go over them next week. All right, this is also a leftover problem from last week. Which of the following shapes must have 4 equal sides? They have to have 4 equal sides. So I know I'm dealing with a quadrilateral. Now, this kind of problem should take you less than a minute. If you are looking at a problem like this, it should take you less than a minute. Why? Because it's a straightforward problem. It's whether you know your properties of quadrilaterals or not. So let's look at each of the answer choices and decide which ones have 4 equal sides. Square. Does a square have 4 equal sides? Yeah, square has 4 equal sides. Check. Quadrilateral. Does a quadrilateral have to have, must have 4 equal sides? No. Does a rhombus have to have 4 equal sides? Yes. Does a rectangle have to have 4 equal sides? No. Does an equilateral triangle have to have 4 equal sides? No. An equilateral triangle has to have equal sides, but it's a triangle. It only has 3 sides. So therefore, my answer is 1 and 3 only, which is D. Now, that's how quickly I would solve that problem, even quicker because I wouldn't have to be talking through it. I do want to quickly and briefly talk about the properties of these shapes before we move on, because properties of shapes is so critical for most of you guys taking exams. Praxis Core, GK, 6 through 12, 5 through 9, even K through 6 has to know properties of quadrilaterals, because those 4th and 5th graders, definitely 5th graders, that's part of their standards. So what do we know about a square? A square has to have 4 equal sides, and it has to have those 4 right angles. What is a right angle? A right angle is a 90-degree angle. So if we do a little flow chart here, a right angle is a 90-degree angle. So a square has to have that corner that's like the side of a paper. The corner of a paper is a 90-degree angle. So a square has to have 4 equal sides and 90-degree angles. You will also see often something that looks like this: 2 sets of congruent parallel sides. When you see that, you know you're dealing with a parallelogram, square, rectangle, because a square and a rectangle are a parallelogram. This is the definition of a parallelogram, which is just a shape. Often we will think of a parallelogram as something like this. And it's a shape that has 2 sets. This is a set, and this is a set. 2 sets of congruent, equal in size. So this line is equal to this line. This line is equal to this line. Parallel. This line is parallel to this line. This line is parallel to this line. Sides. But that's the only thing that defines a parallelogram. It also means that a square, a rhombus, and a rectangle are also all parallelograms because they follow that same pattern. So a square has 4 equal sides, 4 right angles, and 2 sets of congruent parallel sides. The only thing that differentiates a square and a rectangle is the fact that a rectangle doesn't have to have 4 equal sides. So a rectangle is also going to have 2 sets of congruent parallel sides. It's going to have 4 right angles, and it's not going to have 4 equal sides, 4 right angles, but it doesn't have to have the 4 equal sides. A rhombus is also going to have 2 sets of congruent parallel sides, but it's going to have 4 equal sides and not necessarily 4 right angles. So it just traded properties with the rectangle right there. And then a quadrilateral is just any shape with 4 sides. Trapezoid, square, rectangle, rhombus, weird looking 4-sided shape, doesn't matter. Okay? So this right here would be a quadrilateral, but it's not defined by any of those other names. It's not a square, it's not a rhombus, it's not a rectangle, it's not a parallelogram, it's not a trapezoid. It's just a quadrilateral. And in fact, this right here, pre-K through 3 people, is a concave quadrilateral. How do I know that? Because these sides created a cave. It caved in. A convex quadrilateral, all of the sides would be poking out. But because 2 of the sides cave in, it is a concave quadrilateral. All right, let's go ahead and keep going into the next problem. This is the first problem in this problem set that is not a repeat of last week. So I'm not repeating solving the problems. I'm just repeating problems that we didn't get to solve together. If you are just now joining us, welcome. I'm so glad you're here. Make sure you drop in the comment box where you're from and what test you're prepping for. It helps me guide our conversation tonight. I see a couple of people prepping for that Praxis Core and GK Math. And I see someone who is prepping for the 6 through 12. Fantastic. If you want a copy of these slides, just text MathStream1 to the number below, and we will make sure you get a copy of these slides tonight. All right. The measurements of a rectangle are shown to the right. Which is the what is the closest measurement of the perimeter of this rectangle? Ooh, we've got a lot of vocabulary going on right now. They told us this is a rectangle, which means we can assume that these angles are all 90 degrees. Is that helpful for solving this problem? It absolutely is. If they didn't tell us it's a rectangle, we would not be able to assume that those are 90-degree angles. We can never assume unless it's in the picture or in the problem. What is the closest measurement of the perimeter? What is the difference between perimeter and area? And this is not just for a rectangle, this is for any shape. The perimeter is the exterior linear measurement of the shape. The measurement. The area is the interior squared measurement of the shape. So when we're finding perimeter, we're looking literally just for the exterior of the shape, and it's not going to be squared, like that little tiny square that you see, like feet squared. It's not going to be squared because it's a linear measurement. It's just a straight measurement. So if we're looking for the perimeter, I need to add this side plus this side plus this side plus this side. So I already know this is 5, so I know that this is going to be 5 because we have 2 sets of congruent parallel sides. So each side is going to be the same. Then I also am going to look at how am I going to solve for the top and the bottom? How am I going to figure out what this side is and what this side is? Well, I'm going to look at what other information they gave us. They also told us that the diagonal is 16 feet. So how am I going to solve to find that other measurement? I'm absolutely going to use the Pythagorean theorem. Pythag theorem. The Pythagorean theorem says a squared plus b squared equals c squared. This has to do with right triangles only. It only works if we have a right triangle. Remember when I said that 90-degree angle was super important to solving this problem? We needed to know that this was a rectangle because these are right triangles. We've created a right triangle here because this is a rectangle. So I know that this triangle right here is a right triangle. So I can use a squared plus b squared equals c squared to solve it. What you have to understand is that c squared is always going to be your hypotenuse. So the c has to be your hypotenuse, which is your slanted side. It's the side that's across from that 90-degree angle. So I'm going to plug in what I know. 5 squared is going to go into A, plus b squared is what I'm looking for, equals c squared. 5 squared is 25 because 5 times 5 is 25. And 16 squared, I'm going to use my handy dandy calculator. Not everybody gets a calculator, and that's okay. If you don't, you can always do it by hand. 16 squared is 256. Now I'm going to continue this up here. How am I going to isolate the b squared? I'm going to subtract 25 from 256, and I get b squared equals 231. Now, for my people who need to understand how to solve equations, this is a critical step right here. How do I undo a square? Like addition undoes subtraction, multiplication undoes division, squared and square roots undo each other. So if I square root this side and I square root this side, then the squared goes away. So when I square root 231, I get 15.198, which we can just round to 15.2. Now, if you didn't have a calculator for that, what you would do is just think about where on a number line that square root is going to fall. So if I put on a number line, 7 squared is 49, 8 squared is 64. I'm going to run out of room, so we're going to start with 10 instead. No, we're going to start with 12. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. And 16 squared is 256. So this is 12 squared, 13 squared, 14 squared, 15 squared, 16 squared. How does that help me? Well, if you don't have a calculator, but you have to find the square root of 231, you know that 231 is going to fall right here in between the 15 and 16. So you know it's going to be 15 point something. So what does all of that mean? That means that this side is 15.2, which means that this side is 15.2, which means I can now find my perimeter. So I can do 15.2 plus 15.2 plus 5 plus 5. 5 plus 5 is 10. 15 plus 15 is 30, so that's 30.4. 30.4 plus 10 is going to be 40, and 0.4, which is closest to 40. So the closest measurement for the perimeter of this rectangle is 40. Now, here's what I need you to understand. If it said Amy is building a garden and is doing she's building a fence around the garden and she has to go buy wood. How much wood should she buy that's the closest? Well, if I only buy 40 feet of wood, I'm not going to have enough. So if I'm purchasing wood for this project, I would choose 42 because otherwise I'm going to run out of wood. But this did not say that. This said what is the closest measurement, which the closest measurement is going to be 40. Does that make sense? All right. Welcome, Carla, prepping for the EC6. Welcome, Lauren, the FTCE K6 math subtest. Math is your weakness. You are not alone in this room. There are many other people where math is their weakness, and that's why we're here. That's why we offer these free Wednesday night sessions. And then at the end, we talk about our boot camps that we offer as well. So you are welcome. We are here every Wednesday. As we get closer to the holidays, we might take a break or two, but we are here every Wednesday for now. So definitely join us and come back next week as well, because this is not the only Wednesday we're here. We're here every Wednesday. So let's go ahead and move on to the next problem. A unique greenhouse is being built and is shown below. The developers are trying to determine how much paint they will need to cover the entire greenhouse, except for the portion that is sitting on the ground. How many square feet do the developers need to cover the paint? All right. How many square feet do the developers need to cover in paint, not the paint? I was like, that doesn't even make sense. Prepping for the GK. Awesome, Shamice. Excellent. Welcome. This problem is perfect for you. So this problem is mimicked after the famous barn problem on the FTCE website. If you have not seen that problem, go check it out. It's a barn problem that looks like this, and they're trying to find the area of the new barn, and it looks like, or the volume of the barn, and it looks like this. And it always trips people up. And so I was like, you know what? We need to have more problems like that. So I developed a greenhouse problem. So this greenhouse, they're trying to figure out how much paint they need to cover the greenhouse, with the exception of the part that's on the ground. And I should have labeled this as the ground. So I'm trying to find surface area. You have to identify what you're trying to find first. So with a problem like this, we have to have a plan. To be quite frank, if I was taking the GK, I'd skip this problem because this is not a low-hanging fruit problem like Dr. A talks about. If you're not familiar with that, you got to join one of our boot camps or watch his YouTube videos. This is not a low-hanging fruit problem. This is going to take you some time to solve. This problem is going to take myself a solid few minutes. And so I'm not going to waste my time sitting here and solving it, especially if this was problem 2 on my GK. I'm going to go after that low-hanging fruit, those easier problems that I can do quickly, like that square problem we did at the beginning. I would go after these problems because these kinds of problems are going to be much easier to solve quickly other than this. But we're here tonight, so we're going to solve this problem together. So my plan, I need to figure out the surface area. Why am I figuring out the surface area? Because I'm painting it. So I'm not going to fill the greenhouse with paint. That is not what they're looking for. I'm not dumping paint into the greenhouse and finding the volume of paint that this greenhouse can find. I'm trying to cover the greenhouse in paint. So I'm trying to paint the top and the side and the other side and the other side, but not the ground, because it said we're not going to paint the side that's on the ground. So if I'm finding surface area, I need to find the area of each external shape. So how am I going to do that? I need to identify my shapes first. I have to have a base understanding of the prisms or pyramids. This is a prism. So how do I know this is a prism? This is a prism because it has two bases that are identical. So I have a base in the front and a base in the back that are the same. Because of that, and then I have rectangles that are connecting it, it's a prism. If it was a pyramid, it would look something like this with triangles connecting the one base. So it's not a pyramid, it's a prism. What do I know about a prism? The bases are the same. So because of that, I know this hexagon is the same as this hexagon. And I know these are regular hexagons. What is important about a regular hexagon? So if you're not doing GK, but you're doing elementary or EC6, you can still get a lot from this problem because I'm going over properties of shapes. How do I know this is a hexagon? It has 6 sides. How do I know it's a regular hexagon? Because they gave me these tick marks, which tells me every single side is the same, which means every single side is going to be the same on this side because this is a prism. So with that said, how many rectangles am I going to have without counting? I'm going to have 6 rectangles. How do I know? Well, this side is going to have a rectangle that goes out. This side is going to have a rectangle that goes out. This side is going to have a rectangle that goes out. So is this side. So is this side. And so is this side. All the sides are going to have rectangles. So that means I have 6 rectangles. But there's a lot of buts to this problem. So I'm going to have 2 hexagons that I need to find the area of. And I'm going to have 6 rectangles that are all the same. In this specific problem, all the rectangles are the same. In the famous barn problem on the FTCE website, all of the rectangles are not the same because all of the sides of the barn are not the same. But because all of the sides of the barn are the same on this one, I have 6 equal rectangles. So I know I have 12 is this. So this is going to be 12. All of these are going to be 12. So I'm going to have rectangles that are 12 by what? What is that length going to be? That length is going to be 60. So I can find the area of all 6 of my rectangles, but what am I missing? Yes, I'm missing my hexagons. What else am I missing? It said I'm not painting the part that's sitting on the ground. I'm not painting the part that's sitting on the ground. So what that means is I'm actually doing 5 rectangles. You're absolutely welcome, Lauren. I'm so glad that you're enjoying this. And you're welcome, Shanice. Absolutely. So that means I'm doing 5 rectangles, not 6 rectangles. So I'm going to do 12 times 60 because the area of a rectangle equals length times width. So I'm going to do 12 times 60. But then I'm going to multiply that times 5 to find my 5 rectangles that I'm painting. So 12 times 60. Use my handy dandy calculator if you get one. If you don't, you have to use long division or long multiplication. That equals 720. That's one rectangle. 5 rectangles is going to be 720 times 5. And that's going to be 3,600. That is just the rectangles. That's it. Nothing else. So now what we have to do is we have to be able to figure out what is the area of my hexagons. Because I found the area of the surrounding part. We can paint that, but now I have to figure out the paint for the hexagons. So how am I going to find the area of those hexagons? How am I going to find the area of those hexagons? Well, to be honest, I don't keep the area of hexagon formula trapped in my brain, but what I do know is the area of a trapezoid. And if I look at this, I've created 2 trapezoids. So I can do the area of a trapezoid is A plus B divided by 2 times H. A being base 1 plus base 2. I'm actually going to do that instead. Base 1 plus base 2 divided by 2 times H. We lost our feed. Let's reconnect. It seems to do that like a lot. I don't know why. I'm reconnecting right now. So I can use area of a trapezoid because a hexagon is just 2 trapezoids put together. That's all it is. All right, there we go. So base 1 is going to be this, which is 12. We already know that. Base 2 is 20. So area equals 12 plus 20 divided by 2 times H. Here's where a lot of people are going to get confused. They're going to automatically use 32 feet as their H. That's the height of the entire greenhouse. That is not the height of your trapezoid. That is the height of your entire greenhouse. That is not the height of your trapezoid. The height of your trapezoid is going to be half of that because we have 2 trapezoids. So this height is going to be 16 and this height is going to be 16 because 16 plus 16 is 32. So I'm going to do times 16, which is the height of my trapezoid. Let's go ahead and solve that. 20 plus 12 is 32 divided by 2 times 16. 32 divided by 2 is 16 times 16. And 16 times 16 is 256. What does that number represent? That number represents the height or the area of one trapezoid. That represents the area of one trapezoid. Well, that's not the area of my hexagon. I have to do 256 plus 256 to get the area of my whole hexagon, which is 512. But that's just the area of one hexagon. Remember, we have 2 hexagons. So then I have to do 512 plus 512. And that gives me 1,024. And that is the area of both of my hexagons. Now I can add that to 3,600. So 3,600 plus 1,024 equals 4,624, which is not an answer choice because when I did this, I was doing this on my couch and didn't cross-check it. So my answer is 4,624. Where did the 16 come from? Thank you, Andrea, for asking that question. That's a great question. The 16 came from my height, which is right here. My height of my entire greenhouse is 32. And because my area formula was for the trapezoid, not the entire hexagon, I had to take that height and divide it by 2 because I knew that I had this trapezoid, which was equal to this trapezoid. So that means that my height is going to be cut in half. So I'm going to have a height of 16 plus 16, and 16 plus 16 is 32. Does that make sense? Any other questions about this problem? That was a ton of information. Now, here's what I want to ask you. If they said, what is the volume of this greenhouse? What would you do? What is the volume of this greenhouse? What would you do? Volume equals area of... I must be pushing something with like my palm of my hand, which is why it keeps doing that. What is the volume of a prism? That's what we really have to understand first. What is the volume of a prism? Area of your base times the height. And remember, when we're looking at volume of a prism, we're looking at the base being your two identical bases and your height being the piece that connects those bases. So we would have to find the area of that hexagon, which we found to be 512. And then we would multiply it times our height, which the height in this case would be 60, because when we're looking at volume, the height is the piece that connects one base to another base. And so because the 60 is connecting those together, that's why that would be the height in your volume formula. So you really have to understand how to use these formulas properly for them to work. Any other questions about this problem before we move on? Like I said, that was a hefty problem. That's going to take you a while to solve, which is why I would skip it and come back to it. All right, let's go ahead and keep going. This is an interesting one. For the data shown, let this weird U thing represent the median, let M represent the mode, and let this sigma represent the mean. Which of the following is true? U equals M and M is less than sigma. U is equal to M is equal to sigma. U is greater than M and M is less than sigma. U is less than M and M is greater than sigma. All right. This one is one that a lot of people actually would skip because they would immediately see these symbols and they would say, I've never seen those symbols, or I don't know those symbols, or those symbols were not in my study guide or my boot camp or my study book, and therefore I must not know how to do this problem. But I want us to read this problem again and really dive into what this problem is looking for, because when I show you and uncover it, you're going to be like, oh my gosh. For the data shown, let this symbol right here equal the median. So this equals median. They are the same thing. M is going to equal the mode, and sigma is going to equal mean, which is true. And then all they're doing is they're saying the median is equal to the mode. That's all they're doing. So what you notice is they're just doing median equals mode, and mode is less than mean. If we write it out like that, you know how to do that. So really, all we have to do now is find the mean, median, and mode, and then compare them. So let's go ahead and find the mean, the median, and the mode of this data set. How do I find that? Well, I'm going to put them in order first. So I'm going to put them in numerical order. So 2, 3, 4, 5, 6, 8, 8, 8, 9, 11. Now that I have them in order, I'm going to find my mode, which is pretty easy. Mode is the thing that appears the most. It's not the greatest number. It's the number that shows up the most times in your data set. And that would immediately be the 8. So my mode is going to be 8. My median is going to be the middle of my data set. I think of the median as my middle because it's like the middle of a road. In the middle of a road, you have a median. In the middle of your data set, you're going to have a median. So the way I'm going to do that is I'm just going to cross off numbers from each side until I get to the middle. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Uh-oh. I don't have a median. Well, yes, I do. If that happens because you have an even number of data points, what you end up doing is you end up, these both are the median and you find whatever's in the middle of them. So in this case, 7 is between 6 and 8. So my median is 7. If it's not that obvious, you can just add the 2 together and then divide by 2 because there's 2 things. So I can do 6 plus 8 divided by 2. 6 plus 8 is 14. 14 divided by 2 is also 7. So that's how you can find your median. Now, my mean is going to be my average. I like to think of it as being very mean because it makes us do a lot of work. So I'm going to add all of my data points together. 2 plus 3 plus 4 plus 5 plus 6 plus 8 plus 8 plus 8 plus 9 plus 11. And then I'm going to divide by the number of items that I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's going to give me my mean. I'm going to use a calculator just for accuracy purposes right now on this video. We don't have to use a calculator for this. If you don't have a calculator, you don't need one. You could just do it by hand. 2 plus 3 plus 4 plus 5 plus 6 plus 8 plus 8 plus 8 plus 9 plus 11 equals 64 divided by 10, which is going to be 6.4. So my average is going to be 6.4. I always key that 2 times in my calculator for fear of entering it or typing it wrong in the calculator. So if you're using a calculator, I would encourage you, if you have a lot of numbers like that, to do it twice in your calculator. What does all that mean? That means I can now look at my answer choices and decide which one it is. So let's look at letter A. Does the U equal M? Does the U equal M? Does 7 equal 8? No. The Greek letters are mu and omega. I don't know why I said sigma. Sigma's this one, isn't it? I don't even know if that's sigma. I don't know my Greek letters. Hope, thank you for letting me know what my Greek letters are, because sigma is not mean. Omega is mean. So somebody in here knows their Greek letters better than I do, and I appreciate you correcting me. So this is not sigma. This is omega, not sigma. But regardless, it's a funky little symbol. It's a Greek letter, and I didn't know what Greek letter it was. I was just choosing Greek letters when I was typing this problem out. Thank you, Hope. So 7 does not equal 8, so I can automatically cross A off. Let's look at letter B. All 3 of them equal each other. 7 does not equal 8, does not equal 6.4. So that is definitely out. So now I'm just looking at which direction my greater than and or less than symbols should face. So mu, or funky little u, is greater than m. Is 7 greater than 8? I'm going to write that. 7 is greater than 8 because sometimes visually we need to see it. Is 7 greater than 8? No, the alligator eats the bigger number. So that is wrong. But let's make sure D is right, because this is an interpretation problem. They're not just assessing your understanding of mean, median, and mode. They're assessing your understanding to be able to take this and like plop it into this comparison. So 7 is less than 8, and 8, because m is 8, and omega is 6.4. 8 is greater than 6.4. Is that true? Yes, that is absolutely true. So D is the correct answer. So you know how to find mean, median, and mode. So don't let those Greek letters or symbols or whatever you see in a problem throw you off because you don't recognize them. This problem was extremely straightforward, really. It was just mean, median, and mode. But so many people would have given up because they wouldn't have recognized those Greek letters and it would have thrown them off. All right, we have time for about one more problem. So let's go ahead and do this problem. Nope, that's the same problem. The 3 coordinate points of a rectangle include -5, 3, 7, 3, and -5, 7. What is the perimeter of this rectangle? So what I'm going to do here, and I'm going to go through this problem fairly quickly so that I can check back in with Dr. A, because he does have a special surprise for those of you who are still here. So I'm going to quickly graph these on a coordinate plane. -5, 3, 1, 2, 3, 4, 5, up 3. 7, 3, 1, 2, 3, 4, 5, 6, 7, up 3. And -5 up 7, 1, 2, 3, 4, 5, 6, 7. So first of all, what is the other coordinate point of this rectangle? It's going to be right here, because a rectangle is going to have 2 equal sides. How do I find perimeter? I find perimeter, we talked about this earlier, by going around the shape. So if I know the length of this side and I know the length of this side, then I can go ahead and find my perimeter, because I have 2 of this side and I have 2 of this side. So when I look at this rectangle, I know that I have -5 up 3. So I know that this section is -5, and I know that this section is 7. So I'm going to be counting 5 this way and 7 this way, which gives me a total of 12. 12 jumps, if that makes sense. So the length of this side is going to be 12. What is the length of this side? Well, I'm going up 3 and I'm going up 7. So how many jumps is in between that? 4. So to find the perimeter, I'm just going to do 12 plus 12 plus 4 plus 4. 12 plus 12 is 24. 4 plus 4 is 8, which gives me a perimeter of 32. All right, we did not make it through all of our problems tonight, but of course I will include these problems moving forward in the upcoming session next week. So I can't wait to see y'all back here. Lauren, I know that you had said that you had no idea this was here, so thanks so much for joining us. Shamice, thanks so much for joining us. Andrea, thanks so much for joining us. Hope, thank you so much for correcting me and letting me know. Shamice, can you only receive the slides once? I've been texting for weeks and haven't received an email since the very first one. Oh my goodness, I'm so sorry. I actually don't know how that works, but if you could Facebook me So that reminds me to reach out to Dr. A. Facebook me your email address. My Facebook is just Amy Sink. Facebook me and give me your email address, and I will look into that to make sure that you get those other slides, okay? So Facebook me and let me know so that I can get you those slides because I do want to make sure that you get them because I think you should be able to get them every week. And if not, we need to fix that problem. So thank you for letting me know. All right. If you have any other questions, drop them in the comments. I hope to see you next week. And I'm going to go ahead and turn it back over to Dr. A to close us out. So again, thank you so much for joining us. And I'm going to throw it back to Dr. A. So Dr. A, are you here?
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.